Hi Gaita. Hello.
Oh, yes, can you hear me?
Yeah. So, are you also taking troubleshooting errors? Like, because my database is having an issue. I was hoping you could help me solve it.
What type of issue your database has?
Hmm?
What type of issue?
My database keeps crashing. So, like, it keeps every time I log on, it tells me that the database is shut down.
Okay. Uh, some stuff I take off offline. I can take it online when we have enough time. Okay. And especially when it comes to project, I troubleshoot for project live. But if you're having issues with your database or your server and you could not fix it, your group cannot help you, or the class cannot help you, you can reach out to me. Okay, so that's totally fine.
So, reach out to you personally, or?
Yes, you can text me your studio. You can just text me, okay, directly, or since we are here as well, you can text me your student number. That's the only thing I need. You send me the student number and you give me the database name. Okay.
Okay.
Yes.
61, but like, how am I gonna know how to solve it if it happens again?
Exactly. So that is the thing. That's why I say mostly for project I do it live so that you know other people can learn from that. But if I start doing it here, I don't know. It can take maybe minutes. Minutes. It can take 2 minutes. It can take 3. It can take 10. It can take 15, 30. I don't know what causes the issue, and that can affect what we have to cover for the day. Especially today, we have to finish all the PowerPoint. So if I start troubleshooting, I don't know how far we can go. So that's why I will recommend you to give me your student, and whenever I will working on your server, I will let you know. Okay. I will work on your server through VNC so that when I log in on VNC, you can see what I'm doing. I will not talk, but at least you can see what I'm doing while I'm on VNC. I don't know if that one is better.
Okay. All
Yeah,
right.
that,
So do you
that, that,
want me
that
to
is how I
text?
do. Or sometimes when I get to someone's server, I always leave some notes that I'm on your server, and whatever I fix, I will put a comment there about what was the issue, okay, and how I fix it. Whenever I log in on someone's server or I fix any issue offline, I always tell you what was wrong and what I fixed and how I fix it. Okay. So
Okay. So do you want me to like text you?
better to text me. Better to text me. Let me. It's better to text me on WhatsApp, okay, so that it can. I think it can stay there because you text me on this chat. I may open a terminal and later on I reboot my computer and I forgot everything.
All right. Okay. Thank you. But I know it has to do with my encryption key because like the alert logs, that's what it says.
Encryption what?
My encryption key. It says something about my encryption key.
You configure TGE on it?
Yes, but now I closed it, so I don't know why it's still giving me that. It's still shutting down, like force shutdown.
Anyway, there's something wrong on it. Anyway, uh,
Okay.
I will check. Maybe the wallet is corrupted. Okay, most of the time that can happen because of corruption. And I came across wallet corruption on data guard stuff. The-
Okay, so that's just a topic to we're going to
But corruption, it can be a cause of corruption or anything else. So just um, do you have the master key password as well?
yes.
Okay. So yeah, you just send me this information and I will check. If I have time tonight, I will check it. If not, I will tell you tomorrow. I will check it tomorrow.
Okay. But like can I like having can I delete the because it I think it also tells me something about like an archive log that is corrupt because it happened when I was trying to configure Enterprise Manager.
Again, I cannot tell you what is the cause or what
Okay.
is because I don't know what caused it. Okay.
Okay.
So again, you cannot just tell me an error you are having and I give you the fix, because you can have an error coming from different sources. Then it requires different fixes. So I cannot tell you that I log whatever and this is the fix. There is some basic investigation that has to be performed.
Okay, all right, thank you.
Okay, no problem. All right.
Hi, guys.
Hello.
Excuse me. I just want to know, what time do we have for the presentation? Like each group, how long are they going to
Good.
present?
Good. Yes. Same question that was asked in the morning class. It looks like you're the same person. Okay. So that's good. Let me get to your presentation list. From the Word document, I see you guys, there's 4 groups on evening class. We have Silver Spring, we have Landover, we have Buffer, we have Lanham. Compared to the morning class, there we had more people than the evening, okay? So what happened is, for the evening class as well, I will give you guys, we have 1 hour and 30 minutes. Okay, let me see. More topics. No, I will give you guys, yes, 1 hour and 30 minutes per group. Since we have 3 hours, so 1 hour and 30 minutes per group, Monday and Wednesday, okay? So that is what we'll be doing. So if we start at 5, or okay, so the first group we present, make sure you present within the allocated time frame. So after that, the next one. So the 1 hour and 30 minutes covers the question session. Even the questions are part of the 1 hour and 30 minutes. So once we present, then people have to ask questions. In case we go above, for any reason, okay, for any reason, if we go above the 1 hour and 30 minutes, and we get to 1 hour and 45 minutes for any reason, definitely we have to figure out how to complete the presentation by Friday, because 100% sure for the morning class, first of all, I'm almost 100% sure that I will have class with them on Friday, because there is 6 group on the morning. See, there's more people there, 6 group, and I want people to have enough time to present. So I also gave some of them 1 hour and 30 minutes. So it means that at least I'm expecting one group to present Friday for the morning. So I will try to see on my schedule how I can allocate 1 hour or 2 hours out of my schedule to attend that presentation on Friday, next Friday. So for you guys as well, okay, I'm giving you a base of 1 hour and 30 minutes. But if there's any exception, then we can see if the second group can start the presentation the same day and complete the remaining part on Friday. That is the exception, okay? But I see small group, you guys can finish the same day, because I see small groups. I see a group, okay, I see a group like Silver Spring. I see you have 12 members, and another group that present the same day, Lanham, you have 5 members. It means that Silver Spring can take 2 hours, okay? I will give 2 hours to Silver Spring, because we have more people and they have more topics. And to Lanham, I will give 1 hour, okay? So this is how we work. And same thing with Landover and Buffer. Landover, we start. Landover, we have an hour. They can present, they can take less time. It's totally fine, okay? But I'm giving them a maximum of an hour, then followed by the Buffer group, Buffer team, okay? We will have also an hour, 2 hours, sorry, to present. So yes, so it's not mandatory for you guys to have a class on Friday, okay? So it depends on, again, on how fast we finish with the presentation.
Okay, thank you. So I'm gonna make you the host.
Okay, thank you.
Mm-hmm.
Any question? There is something I always like to do. There's always something I like to do, okay? I always like to stay on top of the game when it comes to uh, um, uh, Oracle or any other thing I'm doing. So what I do is I mostly, even after I get any job, I always stay online to keep taking interviews, just to stay active, just to always see how interviews are going. That is definitely what helped me to see what people, all the demand in the market. And it helps me as well when I'm teaching. I know where to pay more attention to, because I frequently am exposed to interviews, not interviews to get the job, but interviews for, again, to see how the market is going and to keep on learning, basically. So basically, for anytime, I always like before to do that with students. So whenever I have a call that's coming, I let you guys know that this is a call that's coming. And some people can see, that was when I was in class. So you can see how somebody can be taking an interview, and maybe that can help you to see how it works, basically. Today, I did that on purpose, okay? And sometimes it will not be long, but I'll be doing it sometimes so that you guys can see how it goes, okay? So I hope if you guys are not interested on how it works, I can just mute myself and talk offline for 15 minutes, 20 minutes, and come back here, okay? It's fine.
So you're saying that you want to take an interview while we're here?
Just a call to see how we take a call or we talk to recruiters, okay?
Okay.
Well, yes, but it should not be long. If it's a real interview that should take longer, I will not put it during the class because I should be offline. So yes, that is the recommendation that I received, and it is quite good because you always stay active and you keep on learning. You almost never forget a particular area because you are always you are always taking interviews, and that's good. All right, any question? Any other question from what we did last class? Because today we proceed. I think somebody said you call me in 5 minutes. Okay. Let me share my. Any question? Let me share my screen first. Okay. So you guys don't have a question. That means you do not read, right? You are not reading, right? What's wrong? Is it tough? Hello?
Yes, Gaetan.
Is it tough? What's wrong?
We're just trying to get ahead in the game. Just it's going well.
Because normally I know with whatever I cover so far, I'm not sure you guys understand everything. I'm not sure. So I was expecting questions, clarifications, doubts, everything. I was expecting that. So please, you guys have to read.
I have a question, please.
Yes.
I was trying to know, like, when they say a table is fragmented and it coalesces the space, what is the beneficiary to the database performance?
Beneficiary?
Yeah, how does it benefit how does it act as a good performance for the database?
A fermented table is not always a good thing for the database. Fermented table means that we have some organization issue of the data at the storage level. Most of the time, a fermented table is not a good thing for a database, definitely. So we always want to, to go with defermentation by most of the time doing some export. Okay. One of the best way of fixing fermentation issues sometimes is to just export the table and import it back to the database. Sometimes people do like that. So export, put it in the DOM file, drop it there and import it back in the database. But I cannot tell you fragmentation is something good for database. No, I cannot tell you that one.
Okay.
It is like blocks. Blocks. It has something also to do with blocks. And it's like somebody tells you that tell you some stuff like, have you ever heard of blockchaining, block migration?
Yes, we have.
Okay, so it's like somebody is saying that blockchain migration is a good thing, and performance-wise, it might not be a good thing for you. Okay, so I see some people are in the waiting room. Okay, let me disable the waiting room. Disable waiting room. Where is that option again? I see there's an option to disable. Let me do that. Okay.
You go to more, to actually participants, and then where you see the dot.
Exactly. Yeah, I saw that. Thank you. Yeah, I think I had to stop sharing so that I can easily see that. All right. So it's like somebody is talking about road chaining migration. That is also something bad when it comes to performance. Very, very bad. That's why a lot of companies implement what we call compression methods so that we can reduce operation like that. So don't always, fermentation is not always something good for the database.
But Gaetan, you mentioned earlier about talking about that fragmentation table that we export to fix it. We export it to the DOM file.
Sometimes the way multiple people do, we export it to, like you guys do export and we import it back. Yeah.
So you say when we export it and then we drop it from the DOM file.
You can drop it, or while you are importing it, you rename it, right?
Oh, okay.
You
So
don't drop for the. I'm not talking about dropping from the DOM file. When you're exporting an object, you export it, it goes to the DOM file. You still have the table on the data in the database, right? Now you can import it back, but you can rename it while you are importing, so that you can have a copy of the table.
Okay.
Recommended to be doing create and select. That is something very dangerous. I don't want
you're breaking.
I'm breaking?
Yes.
Let me check my network. Sometimes when I'm breaking because of the network. Can you hear me now?
Okay, it's good now.
Okay.
So the purpose of exporting and importing was to rename the table.
Yeah, no, it's basically when you export, you import it, the blocks will be reorganized, You have to reorganize the blocks. Sometimes that is how people do by exporting and importing. Instead of just doing the select, create a select, you can sometimes do that. Yeah. So that is a very good technique for fixing. It can be reorganization issues or formattation issues. Export to import in the same database. But myself, I never came across that one, okay? That is just something someone told me that he fixed while we dealt with something like that. So I think that is, if I remember well, that is what he told me when we came across that.
I have another question, please.
Yes, sure, go ahead.
Yeah, apart from slow running SQL, what other scenario-based questions does it come from performance tuning?
A lot of questions. It depends on what they have and what they need. Okay, it's true that most of the time it is SQL, but they can ask you as well a scenario where the database went down and how do you fix it? It can also be a slow running database. It can also be a slow running system. And they just want to see if you came across, database level performance issues or system level performance issues, and how you handle such things, how you approach it. Okay, yes, so those are the three common things that they can ask: system, database, and application or SQL. Most of the time, that is what they need as scenario.
Okay, thanks. Just that I've been hearing a lot about slow running SQL, and it's been like that's most of what they ask. So I don't know.
Yes, because slow running SQL almost covers everything. Okay, with a slow running SQL, you can go everywhere. That is why sometimes they want to see the way you approach it. Okay, sometimes they want to see the way you approach slow running SQL. Because let's take an example. Somebody tells you the SQL statement is running slow. Okay, do you think the SQL statement can be the problem? The SQL statement itself may not be the problem. It could be that the database has an issue. Maybe the database is busy. Maybe there is a change actually performed by someone in the database. Maybe there is a wait event. Some transactions are waiting. So that means the way you approach the scenario of slow running SQL, those people will know if you can deal with a database level issue. Does that make sense? So that is why they mostly ask SQL, because if they ask database, some people will never go to SQL. So by asking you a scenario on SQL, they want to see the way you think. Are you just going to focus on that SQL statement, or you are going to check other areas of the system and the database? And that's enough for them to know whether you can manage performance issue or not.
Thank you so much.
All right, no problem. Any question?
Excuse me. I need to know, was it the moment the table to be master table? One of you query and two tables together, or that's what
I'm not hearing you, please. I don't know. Can you get closer to the mic, please? I'm not getting...
I say, what kind of moment the table you call the table master table? One you query two tables together in a same SQL, or I need to know.
Sorry, I still don't understand. I don't know if someone else understood.
You sound far, Fali. Say it one more time.
I say, I need to know what is the time the table can be called master table.
What time? You're asking what time can we say the table can be called a master table?
Is it what you mean, master table?
Yeah, I heard
Yes.
master table.
Yes.
It depends. You know, we have what you call the master table on data pump. We have a master table on when it comes to also to materialized views and a lot of scenarios. I think in data pump, that's what we call master table, right? The table that keeps track of everything that happened in the export job. That's master table, right? I heard of that one.
I think, but for this case, I'll talk about the.
I know. Yes, I know it's not the one you're talking about, but I just want to bring up, you know, that one as well. So, when it comes to a table to become a master table, it basically means that that table is used to create, okay, maybe other tables, or it is used, it is replicated somewhere. It's like you have a table. It is like you have a source table, and that table you create a duplicate copy of that table or an updatable copy of that table, so that whenever there's an update on the source table, it will refresh other table. So that is when we talk today about the materialized views. Because with the materialized view, for instance, you will create, okay, a materialized view is a table basically, but you create it from another table, and that other table is called master table because it's the master. Whenever that source table is updated, every other target table will also be updated. In that scenario, we call it a master table because it services multiple other objects. Does it make sense?
Okay.
Yeah, that is how you can try to understand it. If I say master table, it means that, or sometimes parent table, it means that you can have a child table. You can have child or child tables. It means whenever I'm updating the parent table, that change will affect anything that is related to the parent table.
Thank you, appreciate it.
All right, no problem. Question? All right. Okay, let me share my screen. We can check. Okay. So today, we proceed with I think okay. So last class we talk about the hints, we talk about access paths, and also SQL plan management. Okay, we said that SQL plan management, the mechanism is the baseline. The baseline basically helps, you know, to avoid performance regression at the database level. It is like whenever any query is coming to the database, if you are running a query for the first time, let's assume you are running for the first time. Oracle, normally you guys know Oracle should, you know, check the result cache or create a new plan for the query. Okay, so that's now Oracle will create it because there is no other plan that is stored somewhere for the query because you just run it, okay? But now with the baseline, it's mostly like a preventive measure. So it's like you run the query, and whenever the plan of the query is good, you store the plan of that query in the baseline. So that the next time, if you run a query any other time, Oracle will always take into consideration what is in the baseline because you consider that what is in the baseline is good, okay? And I said last class that you can do it manually or automatically. So, and whenever a plan is already in the baseline, it becomes an acceptable plan. Now, next time you run the query again, okay, if the optimizer creates again another plan for the query, because for any reason, there might not be, maybe the plan is flushed out from the shared SQL area. There's still a baseline, which is totally different from the shared SQL area. So if the plan is not on the share secret area, we all know the optimizer again, we try to create a new plan for the query. Or if maybe we upgraded the database to a higher version, there can be a newer optimizer. That new optimizer can also create a brand new plan for a query. So now, when the optimizer will create a brand new plan for the query, that plan, the query will not just use the plan. Because now there is a baseline, which is proactive, okay? Every time now, the new plan the optimizer just created, there will be a comparison. Oracle now will compare the new plan the optimizer created for the query with the existing plans in the baseline. So, and based on that, the best one is what Oracle will give to the query, and the query used to, to get to the data. Okay. So if the new plan that is created, it's already in the baseline. That's for any reason. If the new plan the optimizer created is already in the baseline, then it's fine. There's no comparison, right? Because there's a copy already in the baseline. But if it's not in the baseline, that's where the comparison will start. Oracle will compare that new plan, okay, with existing plan in the baseline, okay? And now the best plan when it comes to cost, okay, will be chosen. And that is what Oracle will use and give to the query. Now that plan now, if that plan is a good plan, if that plan that just came in is better than the existing plan in the baseline, Oracle may keep it, okay? So for in the future. So that is how the baseline helps. The baseline is more proactive. So you create a baseline, and then it can still be used. It can be used in the future whenever we are a new plan has to be created for the query for comparison reason. And most of the time, whenever we upgrade the database, we most of the time we capture the baseline automatically. Okay. All the new query, we capture the baseline automatically. We just enable the automatic plan capture, and we disable it later on, so that any query that will be run, that will be captured in the baseline. And now in the future, that baseline can be used for performance comparison. Okay, so it's quite good to avoid performance regression, especially performance regression, whenever there is a change in the environment. So why am I talking about baseline again? Because some people may try to make some confusion between baseline and profile. There's a group that's working on this, okay? So I will give them the chance to provide more information. So I'll just give you a briefing of what is the difference, okay? Because if I talk about everything, they won't have anything to say. They won't have anything to research on. So the profile is more reactive, okay? The baseline is proactive, but the profile is reactive. So basically, you have the secret profile most of the time after a recommendation from an advisor. After maybe the secret statement is running slow, and the secret tuning advisor maybe told you have to create a secret profile. So in that scenario, we had the slowness before we create, before we create a profile. But with the baseline, there's already a plan, and that plan will help you to have a better performance, a better execution plan. So you can see from this diagram that the profile will help to correct issues you have in the past, but the baseline will help to prevent issues you will have in the future. You can have in the future. So there are mostly one proactive, another one reactive. And the profile, again, as I said, whenever you call the secret tuning advisor, one of the options can be the secret profile. And what happened is that the usage of a secret profile, it is now optional to the optimizer. So the optimizer may decide to use the secret profile or not. It's not mandatory to the optimizer to choose a secret profile. So it may use the secret profile or not. The optimizer still have the choice to pick a better option than the secret profile. Okay, but when it comes to the baseline, whatever is in the baseline, if that one in the baseline is also better than the new plan, the optimizer will also pick what is in the baseline. So we should know that profiles are more reactive, and they are it's just an additional option you are giving to the optimizer, okay, for the query. And yes, and it is not mandatory for the optimizer to use it, okay? So yes, we can mostly find it most of the time. When the SQL Chain Advisor gives you the recommendation, it gives you the profile. So I think I gave you guys, I forwarded to you guys some documentation on how to create a SQL profile, okay? I provided this. So you can go ahead and see how to create this manually. There is another tool that is a licensed tool. You guys don't have it. That's why I used the tools you guys have. There's other tools you can get your environment, and you notice that in that environment, they are using another tool to create SQL-based SQL profile. It is fine, okay? It is totally fine. But at least you guys can try to see how we create a SQL profile using, there's a package we use for that. It's a package, this package, the DBMS, this DBMS package, DBMS SQL Tune, okay? I think I described, I gave a link here, okay, on how it works. You can go there and see. So I provided you how to create a profile manually, if you want to do it manually, okay? So it's mostly reactive whenever the performance has occurred. Also, we have something called join method. This is an area that is very, very critical and very, very complex as well. Very critical and very complex. Why? Very complex, why? Because this is something that happens internally. So Oracle, whenever you are deciding you want to get the data from multiple tables, okay, Oracle will decide to use, a join method in the background. Oracle is the one to decide how it's going to join the tables in the background. Okay. Oh, 1 second. Who is going? 1 second. Let me reply to this. Okay, so I was saying that whenever you are trying to get data from multiple tables, most of the time you may decide to, maybe you are trying to query columns across more than one table. So you may decide to join those tables because you want data from more than one table. And now in the background, Oracle may decide to choose a join method depending on how your query, depending on how you wrote your query. So sometimes the join method Oracle will choose depends on the syntax, on the query syntax. And that is how Oracle joins table. Like you can see here on this picture, somebody is getting information on one table, on two tables. Oracle the result can be a join of that. So this is the result you need to give to the user. Now, there are 4 major join methods: nested loop, sort merge, hash, Cartesian. Again, each of these join will be used in the background by Oracle. And the join method will depend on how you are writing your query, okay? How you wrote your query. It also depends on the table size. Are the table big? Are they small? It also depends on how ordered the tables are. is one table on that column has an index or not. So there's a lot of metrics that come into place. And because of those metrics, the optimizer may decide to use either of these, okay, of this join method, okay? So, and you can see here, this is a brief overview of what each of them, you know, the common scenario when you can see those type of join method. And then you can see, for instance, nested loop, they will say that it will happen whenever you are joining two small tables. Most of the time, you may have a nested loop. For instance, two small tables. Maybe the second one, you will see, okay, maybe one table is big, both tables are big, and one is maybe, one has an index, and so on. So on this PowerPoint, I did not provide a lot of details because more details are provided on, you know, a bigger PowerPoint that I did not provide. Okay, this one is the compressed PowerPoint, but I'll also forward you guys, you know, this other PowerPoint. It's not for you guys to read everything on it. It's just because on this PowerPoint, there's more demo on a lot of things that you guys can try. You can try command and see how it works on anything. It's more bigger, but it's more detailed on a lot of things. So you can use this one on, you know, on this join stuff. Where is that? I'm trying to identify those join methods. And again, I just want you guys to have, you know, just a clue about it. It's not, I don't want you guys to feel like you have to master that now. No, I know why I'm talking about it. Because for you to understand, okay, I'm here. For you to master how you can affect Oracle decision when it comes to join method, you need experience. And I can just give you that, I cannot give you that guarantee. You need experience, okay? You need experience to be able to see a sequence statement like this and know if you can affect the join method Oracle will use in the background. Because you can just see, but you don't know, you don't see on this sequence statement the join method, okay? But Oracle will choose the join method in the background. So let me take an example of a query here. I think I ran one query in the morning and I will run it again, okay? So that you guys can see how it works, okay? For instance, I want to take a query like this one. So I hope you guys are trying to see how you can get SQL developer, okay? What happened is I connected to the session as sys user. You guys, I show you how to create a connection. And so I'm just trying to, you know, to query from these tables. I'm just trying first to select and see the result, the output. It's hanging. Trying to reconnect. It's like a timeout. So let me see. Oh, since I'm connected as sys user, so I need to specify who owns the table. Who owns the table? Because it's HR. If I was connected as HR, I think it would have worked. So I'm connected as sys user. Okay. Let me run the query. All right. So the query got executed. Here is even faster. Let me take another query. It's faster because it got executed earlier. So the plan can be in the cache. Let me take another query that can have a different plan. Okay. like the same. Looks like, let me see something. Renal ends, fire. I will explain to you why it is equal. Okay. Yeah. All right. Okay. So I executed the query, and you can see this one is 0.056 seconds. It's even lower than what was before. So this query, for instance, is joining two tables: employees table and department table. The E here is just an alias. Okay, and this query means what? It means that provide me all the columns from HR.employees join with columns from department tables where the department ID, okay, specifically wherever the department ID of employees is equal to the department ID of department, department ID of wherever the department ID of the department table is equal to the department ID of the employees table, and the department ID is equal to 60. So it means that the first indicator will be 60, first of all. So that means this query, what happened is we are looking for the first condition that came into place is department ID equals 60. And the department ID of which table? Table department, because the D is for department. So that means the first scan has to take place in the department table. Once that first scan is performed on the department table, now the result, whatever will be returned now, we will now try to find the matching rows on the employees table, okay? Because we are trying to join. So now let's see, for instance, a plan of this, okay? Let's see a plan of this SQL statement. We can see here that the nested loop, you can see the nested loop in the plan. You may not see that on the SQL statement, but you can see the plan. So it means that Oracle we execute the query on both tables, and at the end, Oracle will join the result. We join both, both results to provide the final output. If we pay attention, this one will help us to, to understand, to read, to see how we read and explain plan, how to read and explain plan in general. So we just look at the explain plan and we just know, okay, we just read like that. This one is a very, very basic explain plan, and I don't see the cost. I want to, okay, we execute another statement and you will see how it looks like. We each another one, okay? So, let me mute for this. So, this, when you have a query like this, the easiest way for me to explain this is that you start reading from the left to the right, and you will go back to from the right to the left again. But how? You start first with, you see these signs, okay? Whenever I can minimize it, it becomes plus, okay? So we always check whatever is at the same level, okay? For instance, this one is the only query or the only operation at this level. So it's not what is interesting. The second one is with the other one, but this one is not an operation. This one is just some XML, just to give some detail about, plan value, database version, and so on. It's not important. So the operation itself, the nested loop. So whenever there is nothing in parallel at the same level with one operation, we jump to the next level, because I will tell you why. Okay, I will tell you what it means. So because there's nothing important at the same level with the nested loop, okay, so we'll jump to the next level. So the next level now is table access. If you pay attention, we can see that we have two operations at the same level. This is where we stop. So it means that one operation was performed first. This is a block, and this is another block of the second operation performed. And if you pay attention, you notice that those operations are performed on different tables. So let's see. Since we have two operations, okay, at the same level, we will now interpret block by block. And once we interpret the first block, the second block, the result of the operation that took place on first block and the result of whatever took place on the second block, that is what will be joined at the next level. That's why the next level now, nested loop, will join the result of whatever was performed on this first block and whatever was performed on this second block. Okay, so now what does this one, what is it doing? What happens is, since this is the first block, we focus on the first block first. We focus on the first block. Now, on this first block, let's go to the next level. Let's ignore the second block, okay? For this first block, since we want to interpret the first block, let's go to the next level. There's nothing in parallel, right? So you can see that this is the only key operation that is performed. This one is just an information. So what happened here, you can just see an index here. So it means that this is a predicate. So this is just, a predicate is just like something that is useful, or it's like what is used to access the data, the condition that is used to access the data. Okay, so this is an access predicate. So to access the data, we need this condition in order to access the data. And this is based on the condition that is specified on the where clause, if you pay attention. So, and you can also see that on the other table, there will be another predicate, but on different table, E, employees. We talk about that one. So on this first one, what happened is what? For the condition where department ID equals 60, okay? On the department ID, there is an index. You can know that just by looking at the object. Okay, you can look just from here. You can see that there's an index called department underscore ID underscore PK. It means that the column department underscore ID on the department table, okay, that this column is primary key on department table. And I told you guys that automatically on any primary key column, Oracle automatically create an index, a bit-rate index, automatically. So that is why, because the condition on the where clause is an index column, then an index can occur. Because this column is indexed, that's why you have an index scan. Okay, because this column is a primary key, meaning there's an index. So it means that that's why you can see here an index unit scan was performed. Why is it unit scan? Because it's a primary key column. And on any primary key column, the result is unique. It's unique whenever you use a primary key column and you use the equality operator. If this, okay, so just those two conditions can guarantee an index unit scan. Because index unit scan means that there's only one result that can be returned. So that is why, because of this predicate, we had first of all an index unit scan. So an index unit scan occurred on that column. Now, after the index unit scan, the next step, going one step above, was a table access by index row ID. As I explained in the past, I said that most of the time, whenever you guys see table access by row ID, it means that an index scan occurred earlier. Most of the time, right? So that is why, because an index was performed, an index scan was performed on this column, on the column department ID, okay? and the SQL statement went back to the table and to return using a row ID. Okay, the SQL went back to the table simply because we are the index table just contains the department ID, but the user wants more information, not just the department ID. The user also wants the first name, employee, all those other values. So that's why after scanning the index table, it has to go back to the table itself. And the access part is what we can call table access by row ID, because from the index, you grab the row ID from the index, now go to the table and retrieve other informations. So the first operation, that's why since there's a unit scan, okay, so only one information, one value should be returned as well on the table. Okay, so that's why the table accessed by row ID, only one row is read from the table. The second block as well, there's another predicate. You can see here that there is a condition D, department ID on department table equal employee ID of department equal department ID of employee table. So that means this is another predicate. Okay, this is another predicate. So this is another hint that should help the optimizer to know how it can access this table, the second table. So now the predicate is e.department underscore ID equals 60, because it's equal, right? If I say that d.department ID equal e.department ID, it means that e.department ID is also equal to 60. It also verifies this condition. Okay, so that means I will go to the table called employees, and I will look for department ID equals 60 as well. That is what is happening here. So now on table employees, because it is employees done department ID, on table employees, department ID is also one of the columns. Okay, department ID is also one of the columns. If you guys don't know, okay, if you guys describe employees, that is the employees, okay? And let's describe the other one. It is the other one is describe HR dot department, right? All right. So you guys can see that these tables have the column department ID as the common column. That's why, okay, they have the department ID as the common column. You can see here the department ID here as one of the columns of HR.employees. If I describe the second one as well, you will also see that department ID is also one of the columns. That is why you can join. That is why you can join them. We cannot join two tables if they don't have a common column. That is why whenever you are seeing a join, they have a common column. Department ID, department ID. The difference is that this department ID is on department table and this department ID is on employees table. Okay, that's why we can join this table. If they don't have a common column, we cannot join them. Okay, we cannot. So now let's go back to the plan I was having. So that means now when I go now to for the second option, okay, the first option is there's a unit scan followed by a table access by row ID. Okay, so the second one, we see that there's a range scan instead of a unit scan followed by table access by row ID in batches. Why is it a range scan? It might not be, it could be a unit scan or it can be a range scan. Okay, even though you see one, but it's a range scan. Why is it not a unit scan? Because the department ID column of department table was the primary key, but the same department ID column on the employees table cannot be the primary key as well, because two tables cannot have the same column as primary key. One will be primary key and the other one will be foreign key. So that is why this department ID on the table called employees is behaving as foreign key column. And on a foreign key column, unlike primary key columns, indexes are not automatically created on the foreign key columns. So it means that an index was created manually on the column called department ID on the employees table, manually. And because of that, okay, because index was created manually, Oracle, based on the table size, decided to use the range scan. If the column was unique, was index, was a primary key, it could have also been unique scan. Okay, so now this one is Oracle decided to perform a range scan. Now, for the range scan, only one value got returned, only one row. So that means only one matching value was found. Only one department ID equals 60 was found on the index. Now, to retrieve other values, we have to go back to the table. And from the table, 5 values were found, 5 matching row ID. So that means we have 5 people on the table employees have belonging to department ID equal 60. Okay, so that is why you can see 5. And you see here batches because just one value, okay, in the column help to get 5 rows. That's why it took it as a batches. So don't mind about these batches, okay? Just mind about what happened is index table access by index row ID. So now this is the number of rows returned after scanning the employees table. This is the number of rows returned after scanning the department table. Now, Oracle now decide now to join the rows returned from department table and the rows from employees table. What happened now is that Oracle will decide in the background to use one table as the driving table and another table as the inner table. So those are the terms that are a bit new to you guys. And that's why I don't want you guys to get confused with this one. So Oracle will take one as a driving table, another one for inner table. What does it mean? It means that for the driving table, for each value of the driving table, Oracle will try to find the matching, okay, information on the inner table, okay? And the nested loop now, after doing that, okay, 5 rows will be returned. An illustration of that is found here on how driving table and inner table work. For instance, let's assume our driving table is employees, the one we got here. The one we got employees, we saw that we had 5 rows, and the other one we had 1 row. So it means that if you are trying to join, okay, it means that we have 5 values, 5 rows on the first driving table and only 1 row on the second table, okay? So it means that for every row on the driving table, we find a matching row on the inner table. For any value on the driving, we try to find the matching row on the inner table, okay? And that is basically how Oracle will determine, based on the size of the table, which one is which join it has to use. Okay, so here Oracle decided to use nested loop. And one of the reasons behind it will be that because those tables are very small. And for 2 small tables, Oracle will mostly use nested loop. This is the takeaway you can get from this. Again, you will master this with experience. Even me, there are some queries that you can give me and if you don't understand, I cannot tell you directly the type of join we use. So I just want you guys to know key differences between those join methods. So most of the time, whenever you see nested loop, it means that Oracle is trying to join two small tables. Oracle is trying to get the data across two small tables. Okay, and another one, you can see another one here, sort merge join. It means that most of the time, one table can be big, another one can also be big or small. But the difference is that at least one of the tables will have an index. So we are dealing with a scenario where we have now two big tables and at least one of the tables have an index. So in that scenario, most of the time you can have a sort merge join. Another scenario is most of the time hash join. Hash join is most of the time occur whenever you are also joining two big tables, but they are not sorted. Most likely they don't have an index to help for sorting operation. In that scenario, you can have hash join. And Cartesian join will mostly occur whenever you are writing your query without specifying the join clause. And an example of Cartesian join can be found on, because other query you will always see join. For Cartesian join, you don't specify the join clause. Okay, let me show you one Cartesian join. So you can see, for instance, this is a Cartesian join. So we are just selecting from employees department, where department ID is called, but I never specify the join clause. And this one is very, very expensive. So please just get the biggest difference between all those join. Don't worry too much about mastering deeper what it means. If you have time, it's fine. And come with question, but that is not our main focus, okay? You are not at the level yet of mastering how join method works. It's good for you to know that they exist. It's good to know in general when one join method can be used over another one. But when it comes to mastering from the syntax of the query and from the execution plan, please, you have to go one step at a time, okay? This can be your first time. Maybe it's your first time to see a join method in an explain plan. So you cannot understand everything today or everything now. Okay, so maybe by going over the same thing multiple times, either in Brontech or at work, you will grab the experience. This is something we teach. I saw a training of 10 years DBAs in Oracle, and we were still teaching them 10 years DBA in Oracle, 10 years and above. I saw a training like that. We were still teaching them this join method because it varies. I cannot tell you I master all of them, because as time moves on with more experience, you will learn something new on this stuff. Okay, so I just put it on the PowerPoint so that you know that they exist. You don't get surprised. Okay, and but you will grab the experience as the time moves on. That whatever I'm saying for join method is also valid for join types. Okay, unlike join method, join types actually are mostly mentioned on the query. So most of the time, you will see somebody will mention on a query. Like you can see someone mention outer join, left join, right after join. In that scenario, you have to specify the join type on the query, right on the query. You can see someone specify maybe left join, okay, left join, or right join, and so on. So this one is completely different, okay? So, and you can also sometimes find the left join and right join on a plan as well. Oracle will specify it on the plan most of the time, or sometime yes, sometime not. Like here, it did not specify it. Maybe if you put a full join. Yeah. So if one of you is interested in understanding this thing in the future, please let me know. But I don't want you guys to be frustrated because of these joins. Why am I bringing the concept of joins? Because this is one of the most problematic issues in the environment. Either when you are dealing with OLTP environment or OLAP environment. That means online transactional processing or online analytical processing, which is also called data warehouse, because these queries are very, very expensive when it comes to resources, CPU, memory. Sometimes time can also be one of the metrics. That is why I brought the concept of join in this class, because most of the objects you will create in the future, whatever you hear about materialized views, cluster table, temporary table, most of the bigger tuning practices are because of join. Queries that are not using join, most of the time, you can just edit the syntax of the query and it's fine. But sometimes there are some queries you cannot tune, especially most of the join queries. Sometimes you cannot tune a query. So you try any other tuning practice, tuning technique, it doesn't work. It doesn't help. In that scenario, Oracle helps you with some type of object, at least, by creating those objects can help to reduce, the performance overhead of those joins operation. So that is why I will start talking about the cluster table and other stuff in the following slide. Okay, so just try to understand some basic information about it. I don't know if there's any question so far. All right, I'm not expecting questions, okay? I know, but I don't want you guys to feel frustrated, please. It's totally fine. It's totally fine, okay? It will not, you almost never have a very deep interview on this join stuff, okay? In this join method. But if you at least know the type of join method and this brief summary I may mention here, that's it, okay? I can guarantee you that you will learn and you will even be better than me or whenever you be in an environment. I can guarantee you that.
So I have a question.
Yes.
Yeah, please, it's not really a question, like a suggestion or a concern. When you're
Okay.
using the SQL developer, it seems to me like you are very fast because I really can't catch what you're doing. And practically, like what you're doing is really new to me. Most of the SQL that you're running, I don't even know where they're coming from. And I just wish you take some time to explain what it means. Like the E you put in front of this department, it was later you later explain and I understand. But generally, when you're using the enterprise manager, it's like I'm often lost. Excuse me, the SQL developer.
Yes, that's why I want you to download SQL Developer so that you can be more familiar with this platform. If I'm not spending too much time, I think I basically, okay, you said that later on I explained a SQL statement, yes. But also, yes, you may not expect SQL statement to be as the one you ran before. Because I can tell you that any single SQL statement you ran before were basic SQL statement. Okay, so you will find SQL statement with 10 rows or 10 or 20 rows, big SQL statement. So, but at that time, yes, that is why you guys did SQL Fundamental. I think on SQL Fundamental, you were able to have SQL statement that can help you query more than one table. SQL Fundamental 1, SQL Fundamental 2. I think that was DB2. I think you had SQL Fundamental 1, SQL Fundamental 2.
Yes, so we have it. We did it.
Yeah.
And even the SQL developer, some of us have it.
All right. So yes, this query was just, a query, an example of a query that uses joins, okay? Like you see a join. So whenever you want to use a join, you specify the keyword join. And when you specify the word join, you specify the tables you want to join. That is why it looks like this. And join mostly goes with a column. You are joining two tables before they have a common column. And the common column on this particular example is department ID. Yeah. So that is the common column on all the table. And yes, I think you understood what the E means, which is the alias of employees, and the D is the alias of department. So that is what it means. So yes, at least I think you should be able to understand at least, the syntax, but you cannot, okay? For now, I can tell you, you cannot just look at this SQL statement and know how to tune this SQL statement, or you cannot know just by looking at the SQL statement if it is poorly written or not. That's why I was saying that to have that experience or that knowledge, and to have that knowledge, you need some experience. By having multiple queries like this in your environment, or by practicing, okay, you can know that, okay, maybe if I reverse the order, it can run faster. Maybe if I change something, it can run faster. Okay, so I'm not expecting you guys to see this query like this and understand exactly how to tune it. All right. So for now, your focus is to, what you guys should know, okay, is to know how to get an explain plan. It's one step at a time. Know how to get an explain plan from SQL Developer or SQL Plus, and know some key areas of the explain plan. That's what they mean. Even in the interview, they will not mostly tell you how to read an explain plan. But I told you, for instance, how you approach, which is good for you because you'll be working. So, but some of these columns are not populated because this SQL statement is a very small SQL statement. That is why if I had a bigger SQL statement, I had another one here that was really good. And I knew that it can help me to get some important details. I think this was the query. So by having SQL Developer, you can open a terminal like this, okay? It is text. So paste it. This is another query that also helps to get data from multiple tables. And here, customers table, product table, sales table. You can see that the condition are, whenever you guys see on the condition, there's always a common column. But the common column is from different tables. If I execute, okay, this table belongs to a user called SH. So if you want to execute any query on SQL Developer, you click on this button. You execute the query. So this query, for instance, you see here 50 row fetch in 9.18 seconds. It doesn't mean that's all. You press Ctrl-8 because SQL Developer displays in 50 rows. So you see that was not completed. So we had more than 50 rows displayed, more than 50. So you see now that in total we have 416 rows. You see how many seconds it took? 21 seconds. So this one definitely there's a join because we are using multiple queries, but we don't see a join clause here. So we can see the plan of this query. Let's see the plan. So you see that it's scary. All right, I can tell you guys that for you, pretty new, let me see. Even this full screen cannot take everything. Okay, this one is quite big. You see a lot of nested loop, a lot of stuff here. Okay, that is an example of a plan with a lot of predicate. So whoever wants to read this plan will not be afraid of reading it. You will still go from the left to the right. You still here. This is the only one. So this will be the last operation. Go to the next level. There's nothing apart from the XML. Go to the next level. There's something at the same level. So that means after an index scan, you can see here on the primary key, after an index scan, then the index scan will be joined with the nested loop. And this nested loop is the joining of operation performed by partition and table. So don't be afraid of this one, okay? The way I read is the same way. You just go from the left to the right. And when you get to the first block, you focus on the first block first, you read the first block, and then you focus on the second block. And once you read the second block, now the nested loop will join the first block and the second block. So what happens here is that what you guys should know, you see here, we have more matrix on this example than the previous one. We can see here, for instance, that we have another column. Okay, these are the options. Uniscan or whatever, okay? Index Uniscan, we talk about Uniscan, we talk about table access by row ID, okay? So this is partition start. It means that this table called product, sh.product is partition. So partition start means the first partition is used and it stopped at the 28 partition. So it used all the partition of the table. So partition start, the first one he used, he started using the first partition and then he stopped at the 28 partition, the partition number 28. So that means this table, the table called cells is partition. It's a partition table. You can see here sh.cells, partition table. So this one is not something that recruiter can be asked. This can see cardinality, how many rows were returned. Oh, no. What's wrong? Okay. Partition ID. Okay, you can see cardinality. Okay. I did not have the chance to explain to the morning class this one because I was caught between a lot of meetings. But I will tell you something very important. Don't mind about all those stuff. How can you know where to tune on a plan when you see a plan? This is what matters. How can you know what to tune when you see an explain plan? By seeing these explain plans, pay attention. The total cost is, the total cost, if you see, right, is 209, all right? The total cardinality is 521 rows. Now, when we see, we can see now that the first 521, let me see if you guys can see all this stuff together. Okay, we can see that whenever we perform this operation, see first, because when you perform an index Uniscan, only one row was got returned, only one row, so it's fine. But when we perform the other index scan, this index scan, okay? When you perform the other index scan, one row got returned. But after the index was scanned, the next operation was what? After this index scan, the next operation was a partition range. So it has to read all the partitions from partition 1 to partition 28. And this is what increased the cost. That means by reading from partition 1 to partition 28, we got 521 rows returned. It means, and the cost was 208 seconds of CPU use. So we can see now the total cost is 209. It means that Oracle spends most of its time doing this operation with the cost of 208. So if you want to tune this query, you will try to see how you can avoid this partition range operation. Because that is where the query is spending more time. Okay, so most of the time for a query like this, if it can be tuned, you will just select the query and you will see somewhere here the SQL Tuning Advisor. You just run it. And the SQL Tuning Advisor will check that query and will tell you, okay, if there's anything you can fix or you can troubleshoot on that query, or if you have to rewrite the query and so on. So this is just how easily we run a SQL Tuning Advisor from SQL Dev. I will have to do this with the morning class because I did not. Okay, so you must, because you don't have an eye to easily see what is wrong on the query, okay, the easiest way for that is just to run the SQL Tuning Advisor from here on SQL Developer. That's why I want you guys to have it. And once you run it, it's running. It's running. It's trying to analyze this query. And at the end, it will give you an overview of whatever can be as a finding. If you have to create an index, if you have to rebuild an index, if you have to gather statistics, if you have to do anything, it will give you that. So the task is actually running. So that is what I want you guys to know, okay? Not that much. I don't want you to get confused. And
could you go back to the explain plan for a second?
The explain plan is this one, yeah.
Okay, so you said it was the cost and the cardinality?
The cardinality was the number of rows, 521 rows. That means this operation itself returned 521 rows. And the equivalent, the cost is 208. So that means for this partition range operation, 208 CPU second of CPU have been used just for this operation. But for the unit scan, only almost zero CPU. You see zero, but it's not zero because it's close to zero. So it means the problematic operation here, it is this line first. The first line with the highest cost is this line. You can see the total cost of the operation is 209 because the total cost is the one on top, all the way up. But just for this operation, this line, the cost is 208. It means that this is where Oracle spends most of its time. Now, if you want to tune a query, if you find out a query is problematic, it's for you now to see how to how to reduce the cost. Okay, that is now the job, what you can be doing. So, and somebody experimented, maybe, okay. The SQL Tuning Advisor task is still running, okay? Somebody who's experimented with C, look at this query and say, oh, let me not use the in, let me use the between. And they can have a better thing, a better cost, and so on. So depending on how you build your, how you are familiar with, with the example. So the task is taking some time because it's a quite big query. So actually Oracle is hard to look at all the statistics, everything, and recommendation. So that's why it will take some time before it completed. So when it's completed, we can come back and look at it.
So I have a question.
Yes.
So with a SQL Advisor, we write the SQL statement, or we just give a maybe recommendation?
It will give you a recommendation even to rewrite. If it thinks that there's something you should write a query, it can give you the recommendation to rewrite it. It will not rewrite for you, but it can give you a better query as well.
Okay.
Yeah. But before you run a SQL Tuning Advisor, make sure you also have up-to-date statistics, because the SQL Tuning Advisor also uses AWR statistics before it can give recommendation. If those statistics are not reliable, the SQL Tuning Advisor can also give you wrong recommendation. That's why you always have to make sure that your statistics are also up to date. before you consider whatever the security advisor is saying. And you will not implement it. You will use it, whatever is recommended. You go to the test environment, you test it, you see if it's effective, and now you come to the application team and suggest them that they can update their code instead of using they can use the between and so on. Okay, so that is something a bit more advanced so far. I just want, yes.
I don't know, how would you know if your certificate is old?
I think I gave you guys the query, right? I show you how to identify the last time statistics were gathered. And I also told you guys, why is my keyboard not working? Well, because, okay, this one is freezing. I don't know if there's a database I can connect to here. I don't even know. There's a option owner. Okay. Oh, it's segment name. Not table name. Okay. Let me see. Table name is for DB_table. This one will give you the size of the table in megabyte. If you want it in gigabyte, you divide again by 1024. So this one will give you the size. So if you have the size of the table, okay, of yesterday, you can get this. Let me just. Just select these two without specifying the owner. So, for instance, for the segment name called department, the size is 0.06 megabyte. Okay, so we can see the size here. So it means this is the actual size of the table. Okay, so if the table has grown, you can still query this table and know. Okay, what do I query again? I query GBA segment. Okay, so you can still query this table. There's a metric here I'm looking for. Okay, no. So based on the statistics, you know, the size when you got the statistics, okay, or maybe from the AWR or any statistics that will gather, the size of that table at that time, when you have it, you can now get this size and you can now, you know, make the ratio to see the percentage of growth of the table. And now when you have this size, you know the percentage of growth, if the difference is more than 10%, now you know that, okay, statistics will be still, because you compare this actual size with the previous size the last time statistics were gathered. And I think I also gave you guys the command, okay? We can see, for instance, that the last time statistics were gathered on this table employees was on July 2014. So that means this is when this sample schema was created. So since then, statistics never gathered statistics on this table. This is quite normal because whatever you guys are using now, the software you are using is quite old. Okay, so that means, and I just created this database. I created it last time. So since then, statistics never been gathered. So you can just check the last time it was gathered. You can see you get the size of the table when it was gathered, and you get the size of the table now as we did, and you just perform the ratio to see the percentage of growth, and that's it. Okay.
Okay, thank you.
All right. So this job is taking forever, so we will not waste time waiting for this. Okay. Any question? So I will not spend time as well on result cache operator because we explained theoretically what was the result cache, what is it used for. We said that the result cache helps to store the result of a query, but it is not enabled by default. So you need to enable it either for a particular table or for a particular SQL statement. So if I enable the result cache for a table, it means that whenever you run a query on this table, the result of that query will be stored in the result cache, all right? And the next time, if that result is still there, if it's not yet flushed out, you can still get the result straight from there. If you don't want to enable the result cache on the entire table, you can enable the result cache only on a particular SQL statement. So the result of this SQL statement will go in the result cache. This is a hint. So the result will go in the result cache. So the next time you run similar SQL statement, all right, you can grab the results straight from the result cache without having to go to the shared SQL area. And you want to flush the result cache, you want to empty the result cache, you run this query. All right. So this is just basically how we can create a table with the result cache or alter a table with the result cache or add a query result to the result cache manually. But for that, you need a bigger SDA because the result cache is stored in the shared pool. So if you want the result cache to store multiple results, then you need a bigger shared pool, okay? I did not mention here how, okay, you can query this VDOLA to see whatever, okay, is in the result cache. There's also a package you can use to allocate the size for the result cache, okay? That was not part of this presentation because you don't need that one. But if for a result cache to be used, you need a bigger memory. You need a bigger shared pool, okay? If the shared pool is small, the result cache will also be small. And if a result cache is small, it means that the result of a query can be flushed out faster because it won't stay there longer, right? It can be flushed out faster, definitely. So I wanted to get with the John. Why was I talking about Johns? Okay, because John again are very, very expensive. Those are the biggest headache. And as I told you guys that sometimes you cannot fix John because the SQL Chain Advisor is running. Okay, I could have edited this query and wrote it some differently. You could have seen that maybe the plan can be better than just by updating the query itself. So because Johns are expensive, really expensive, just the small query I ran, you guys saw that it took 8 seconds. You guys maybe see 8 seconds is not bad, but it's very dangerous, it's very huge, it's a lot, 21 seconds. It's a lot in the database. So it means for 21 seconds, if this SQL statement is accessing a table, the table can be locked for 21 seconds. It's very huge. So that means we have to figure out how we can, affect not just the time, but also the amount of CPU it's using. That is part of the tuning process. So because sometimes we cannot fix the query itself, Oracle gave us alternative. One of the alternatives to fix expensive Johns, is using clusters. Clusters table. What's a cluster? On the previous scenario, okay, just to know, when I finish this one, if you guys want, you can take a short break. What happened is what? By default, unless you are using compression or you are using this cluster, by default, on every single Oracle block, all the rows of that block belongs to the same table. So a block has an area for metadata, and a data block has an area for data. The area for data, most of the time, contains the rows of the same table. So it means that if I want to join two tables, I'm 100% sure that I will have to read different blocks. I will have to read from different blocks because each block contains the rows of a particular table. You cannot find, I'm saying by default, whenever you're not using compression or you are or whatever I'll be talking about now called cluster. So it means that if I'm doing join, as we said joins, the blocks of the employees table, all the rows of the employees table will be stored on some particular blocks, set of blocks, and all the rows of department table will also be stored on another set of blocks. So the join will just get data from the employees blocks, and join them with the data from their department blocks. So you are reading from multiple blocks. And reading from a single block is an expensive operation. That is why sometimes we are trying to reduce the amount of block Oracle have to read. Because don't just think that you just get to the block and easily find what you are looking for. Whenever Oracle gets to the block, Oracle has to go to the metadata area. From the metadata area, Oracle now, from that area, we try to identify the position of the column from the metadata area. Once Oracle identifies the position of the column, Oracle has to go one column after another to retrieve the column you want. So you should know that even in a block, it still uses some CPU even to retrieve a data from a particular block. So it's an expensive operation whenever you are reading multiple blocks. Now, with the clusters, you can create a cluster. That means you create an area like a bucket. And in that bucket now, you come and create 2 tables or multiple tables in that bucket. Whenever you create those tables in that bucket, now a block can contain the rows of either one of them or both of them. In this scenario, whenever we are joining, you can just get to a block and you get the data from both tables, right? From one block. You don't need to get from one block and go and look for the matching row in a different block, which is quite expensive. So just from a single block, you can get the data from both tables at the same time. This is the secret of, this is what happens when you're using cluster table. And it highly improves the performance of every join operation. It highly improves. But now there are some conditions for this to be used. What are the requirements? You should make sure that the tables you want to add in that cluster, in that bucket you are creating, make sure that those tables have a common column. At least one common column, at least one. So if you pay attention, the sales table has product ID, the product table has product ID. That's the requirement. Even to perform a join operation, they should have a common column. And another difficult part is for you to estimate the best size you have to allocate to your cluster, to the bucket. Because if you give too much size, it might not be used efficiently. If the size is too small, it can be an issue as well. So one of the biggest challenges every DBA has, that's why people don't use it a lot, because it's very difficult to estimate the best size to allocate. If you give too much, maybe Oracle needs more block for other operations. So that means you are taking, whenever you create a bucket, right? All the blocks in that bucket can be used only by those tables. So Oracle will not touch those blocks. That is why you don't want to take that risk by creating a bucket with some blocks that may not be used. So that is one of the most difficult part when it comes to cluster. But if you have that experience, based on your, based on what you see, based on, the percentage of growth, if you can access how fast the table grows, if you can, see all those metrics and create a good cluster, then you save the environment from a lot of high CPU or I/O usage. You will save queries, a lot of queries, because that is a very, very good tuning technique. Okay, I hope it makes sense what I just said. Are we there?
Yes,
Yeah,
it makes sense.
it makes sense.
So, cluster works like, that is a good option. Another one is, I will skip this one first and I will come back to this. Another one is temporary table. They also work like cluster table, because the issue with cluster table is because how to estimate the best size. That's the biggest challenge. Okay, but with the temporary table, you don't have that issue. What is the temporary table? The temporary table as well is like the result of a query or the result of a join operation. Let's assume you have a query like this. A query like this is, this is how we create a temporary table, for instance. And this temporary table is other tables. So it looks like something like it's like the temporary table. We have the first table, we have the second table, we have the third table. We get some information from this first table, we get some information from the second, we get the other one from the third, and we build another table with that. So maybe on this table had maybe 5 columns. I need only some information, maybe some 1 or 2 columns and some values of that column. Maybe this one as well, I do the same. And I build a table that contains all the columns I need and all the rows I need. Okay, now this table I built will be stored where? In the memory. Now, since it is stored in the memory, it means that you are sure that you will not have cache misses. So any transaction will run faster because it is stored in the memory. So that's the result. All the other tables can still be in the disk, on the disk or whatever. But the temporary table will be stored in the memory. So the join operations, any other join operation can just use the temporary table that is in the memory. Okay, so that is how it works. So but now, we can have 2 types of temporary table. They can be global. On global, we can find it on 11, 12C, and so on. Whenever a temporary table is global, like you can see here, it means that multiple sessions can use that table. Let's know something. The application user doesn't need to know that you are creating a temporary table. Maybe after investigation or maybe after your testings, the team decided to use temporary tables for any reason, right? You guys created it. And once you create it, it is in a memory. The advantage is that the queries will get the result faster, right? But the disadvantage is that if the instance crashes, you are losing it as well. If the session ends, you are losing it because the memory, that's how the memory is, right? Whenever you exit from you kill your session or you end your session, whatever you have done goes away. Okay, so that is how it works. So any other session can use that temporary table. So that means if somebody was running his query before, the optimizer may decide to use the global temporary table without even the approval of the user. That is something the optimizer will consider on his decision. So it can speed up any other join operation that is trying to access any of these tables. Okay, so it is global. So global is shared by multiple sessions. So you can create it, but other people can use it. But it's just on 18C and above, okay, that you can create a private temporary table for your own session that is private to yourself. It's like you are dealing with database link. You guys know you can create public link and private link and global, whatever you guys learn. That's the same thing here. So if I create a public database link, it means that multiple sessions can use the database link. So it means also if I create a global temporary table that is stored in a memory, it means that multiple sessions can take advantage of that.
Yes, I have a question, please.
Yes.
So for the let's say you're trying to do like payroll, right? So will you have to, can you use a temporary table for the payroll?
if that payroll has to access, has to access those columns. If you notice maybe that the job that you are running for the payroll, okay, by implementing temporary table will help for that, you will do it, right? You will do it. If it will help for that job, you can do it as well. It's totally fine. If the payroll, for instance, has to access 2 tables, and you see that expensive operation, okay, so you can create a temporary table that is stored in the memory so that when that job is coming to run, it will mostly stay in the memory. If anything has to be retrieved from the disk, maybe we retrieve additional information from the disk, but it will mostly stay in the memory because most of the result is found on the memory, okay? It's found on the temporary table. So whatever I'm talking about temporary table is valid for every single job. And it is not just for John. This one is not just for John's, okay? It's not useful just for John's. It's also used for any long-running query. So if the payroll is taking longer, expensive, you can consider using it if it's okay, important for you. Does it make sense?
Yeah, so in which part of the instance will it be kept?
Memory, when I say memory, is
yeah, I mean like what part of the memory?
But of course, those information on the block will be stored in the buffer cache.
The buffer cache, not the keep pool?
The buffer cache, in the buffer cache, the keep pool is part of the buffer cache, right? It's the special area of the buffer cache, right?
Okay.
The keep pool, the recycle pool, NK buffer, those are special area you create from the buffer cache. Because they store blocks, right?
Right.
Which area of the memory store blocks?
Buffer cache.
Okay, so when you create a keep pool, what does it mean? It means that it store blocks longer than what the LRU algorithm, right? They allow you to do, right? So you are still creating an area from the buffer cache, an additional, an area that can store blocks from the buffer cache. All right. Same thing for the recycle or the NK buffer. Those are the area that store blocks. So most of the time I call all of them buffers, buffer area. Okay, so this global temporal table.
Excuse me, sir. I got just a small question.
Yes.
If the session is stopped, this one is gone. That means like if the database is shut down.
If the database is shut down, or you, the person who created it, you exit your session, it is dropped.
Oh, if maybe the okay. Thank you.
If you are self, right? If you are self, you exit your session. If for instance the sys user exit the session, you are going home, you exit everything, it is dropped as well.
Okay. Thank you.
No problem. Okay, are we good? Do we need a short break? 15 minutes?
Yes, please.
All right, let's come back at 7:30, okay? Let's relax a little bit. All right. Let's finish this. So we talk about temporal tables. So we said that those tables are very important, you know, so when it comes to queries, okay, expensive queries, and they are stored in memory. The other one is materialized views. There's a group that will present this one. So I just give a briefing, okay, an example of when a scenario when the materialized view can be used. Let's assume that you are in an environment, okay, and you have different departments in the company. You have the HR department, okay, where you have people from HR, everybody. You have a sales department, you have finance, people from finance department, those who are people from payroll. So they're the ones to take care of those payrolls, everything. People from IT department and so on. So we have multiple departments, okay? So now we have an employee that just got in the company. We just hire an employee. And what happened is that employee has to be has to be registered on all the departments. Everybody, on not all of them are okay, but some critical department. Let's assume the person is from an IT. It's an IT person, okay? So that means the person should be in the finance department, should be recorded in the finance department, okay? So that you can, you know, regarding your finances, your information should be on the HR department, who has all your personal information and everything. And okay, because that's where the HR has everything, right? When it comes to benefit, or when it comes to whatever is private, social security, everything, the HR is aware of all those details, okay? But people from the finance, they just maybe need stuff like your employee ID, your name, okay? They don't need your social security, okay? They don't need that, because what do they need that for? And also other department, maybe the IT department also needs some information from you. So do you think that when you get hired, okay, by a company, the HR hires you, do you think somebody has to type it down as well on all departments? Otherwise, that's how it should be, right? That means finance also has to take your information and type it and register you manually. And the other one also has to do the same. That is maybe for a company, a small company, because sometimes you want things to be automated, such a way that when the HR will record your data, automatically some of those information will go in another table, on a different table. Okay, maybe directly some of the information will go to finance or IT and so on. So you can either send those information manually, or okay, that can be automated depending on your profile. Okay, so now come the example of material view. Let's assume that the table that is created on finance is a material view table. It means what? It means that whenever we add a new employee on the HR table, some information from that HR table will be transferred to the finance table. Some of them, whatever they need. So they don't need to type it manually. So it means now that the HR table now behaves like the master table, and the finance table is a material view. Okay. So next time, whenever a user is added automatically, okay, or you can do it automatically, or it can be done manually as well. The result, that record will also go to the finance table, okay, and that finance table is a material view. And material view are refreshed, okay. So it means because it's an expensive operation, because it can be done automatically, such a way that when you add an employee, immediately that change also goes to the material view table. Or it can be done manually. Whenever you add an employee, it doesn't go there automatically. The information goes to a log file, and you can just refresh that log file. And after you refresh it, the change can now go to the target table, also called the material view table. So that is an object. So it can be created from one or multiple tables. Okay. So whenever you have a query, maybe the result of the query is, maybe the query is, maybe the SQL statement is querying multiple tables. Okay. The result of it can be a column or a table with multiple columns. Okay. So now that table is not just a regular table. It is an updatable table. So it means that table, whenever any user perform a change on the master table or master tables, that change can also be replicated to the material view table. So that is how it works. It's an object. Okay. It can be used for refresh, or it can be used for data replication. Okay. So that is how it works basically. And how does it help for performance tuning? Because you cannot decide to create a material view. Okay. You cannot decide to create a material view instead of having multiple tables to be queried using joins. You can create a material view that is the result of all those joins. Okay. Then the material view now is also, you also store it in the database. Okay. So now, whenever we are running a query, immediately the query now will now go to the material view and get the result from there. Instead of having to join again the table, immediately the result can be found on the material view table and it can be returned to the user. What is good about it is that, as it is for temporal table or cluster table, it is transparent to the application team. So what happens is, whenever you create a material view, the query transformer will consider it while making its decision. The optimizer will consider it while creating the plan of a query. So it means that maybe before the optimizer created a plan for a query, but that plan was not that good. But now you created a material view, the optimizer will take it as an option. The optimizer now will also try to calculate the cost of using a material view. If it finds that using material view is better, automatically the query transformer will transform your query, or we will rewrite your query to use the material view. Okay, so it's transparent to the user, to the end user. Okay, so and they are also very good for joins or any long running query. Okay, but what happens is, since they are database objects, in their space, right? They have to be stored somewhere. They have to be stored somewhere. Okay, and they also grow in size. They grow in size because if the table is growing, if a material view relies on a master table, okay, and we add a new row to the master table, the material view also has to be updated with a new record that was added, okay, in the master table, as you guys can see here. So it means as the master table grows, more likely the material view table can also grow. So this is one of the disadvantages of using it, because it needs space. You're giving you the benefit of performance, but also it requires some space, okay? And it's a database object. We can stay in the database longer. So it's not like temporal table that are deleted after the session ends. No, temporal table are deleted since they are in the memory, and in the temporal table space in the memory part. Okay, temporal table space on the memory part. So it's volatile, because whatever is on the temporal table space, okay, automatically is after a session end is cleared, because it's for a temporal session. Okay, so but material view are not temporal. So even you can come back and it's still there. It's a database object that is created and it stay there persistently. Okay, and yes, so I took the example of the HR department and the finance department just to illustrate, okay, how it can help to replicate data. But most of the time we use it manually. We perform the manual refresh because even though you can perform an auto commit, so that whenever a record is added on the master table, automatically it goes to the material view table. Most of the time we prefer to do that manually because the automated method is expensive and it can affect, okay, transaction in the database. So most of the time, what happens is what? If you get to environment, you will notice that most of the time, they will tell you that, okay, they hire you today, but you have to wait one day or 2 days for everything to be set up before you start working. Why? Because even though the HR added you now, the data may not be replicated in all other departments right away. Because most of the time, if they are using material view, they cannot just refresh the material view right away. So what happens is, at the end of the day, they can now refresh it so that all the changes that took place that day in the HR department can now go to other departments. And they can receive all the changes because it's quite expensive. Okay, so the group that we presented, if they have more to say, they will definitely have more to say, and they also show us how to create the material view, and also show us how to refresh the material view. Okay, so I think it's quite interesting. Okay, when it comes to performance, and I will talk about this again a little bit when we get to the third project that is called Oracle Golden Gate, because Oracle Golden Gate came to enhance, some stuff Material was doing. As I just said, right, because Material is expensive, but if you want to refresh the Material View table automatically, whenever there's a change on the table, Golden Gate came to fix the issue. So the Golden Gate, it helps for real-time data replication. So as you are adding a data in the HR table, automatically the data can also go to the other table without affecting the database performance. It's a tool that comes to fix real-time data replication. But Material View are not good when they are working in real time. It's better to use it to refresh it when the environment is not busy. Any question on this?
Yeah. I just wanted to know, like, what are some, like, hello?
Yes, go ahead.
Yeah, so when will you want to use a complete refresh and an incremental refresh? Taking the example that you gave us with the HR table. If you, let's say an employee gets fired, would that be like an increment? That would be incremental refresh, right? Versus complete refresh.
Incremental refresh just means you are just, on the material, you are updating the Material View with a new record. With a new record, that means the Material View table is there, and maybe the master table is also existing. So you're adding new record in the master table. Okay, if you are doing an incremental refresh, that means you want only the changes that were performed on the master table to go to the Material View. So we are just adding on top of what was already there, new record. But the complete refresh is like you are recreating it from scratch. So it's like you are deleting whatever was there and making a complete copy again of the data, okay, in the Material View. So it's more expensive. Only if you understand what I'm saying.
Yes, I understand.
Yeah, so most of the time, okay, depending on the environment, I mostly came across this type of Material View, incremental refresh, because you don't need to, to drop this. You don't need to drop whatever is here, the existing data. You just add on top of it. You may find yourself using a complete refresh if maybe you want to change the Material View maybe you want to remove some columns or some data on the existing material view. Okay, so now you can decide to perform a full refresh again or a complete refresh. That will help to recreate the material view from scratch with the new data. Okay, and this one is the fastest one. Okay, incremental is because you are just adding new data on the existing one.
Excuse me. What in the material view we say?
Please come closer, please. Please come closer to the mark, please.
I'm so sorry. Maybe my connection. I don't know.
Yes. Please go ahead.
I say one is the material view is the one. What kind of way one we say is enabled to query will create? That's mean like you create the material view and the same database.
You can create on a database on a different database. Okay.
Yes.
Can be created on the same database or different database. If you have a query, okay, that runs on one database and maybe needs some data from another database, material view can help to do that. Instead of using database link, you can use you can just query straight the material view instead of having to go through the network to get data from the other one. You guys did database link, right?
Yes, but
database link, you guys learned that you can query a table remotely, right?
Yeah.
Right.
But the data has to go through the network, so it's expensive. You have to check the network. Yeah. But material view, if a user is connected only to this database, the user doesn't have access to the master database. That means, let's assume this is HR database, this is a finance database. The user can just access finance database, but we need some record from HR database. So it will help. So you can create a material view table remotely, and the user can just get the data from here instead of having to connect to the master database. So you can also create it remotely, definitely. Does it make sense?
Yes, it makes sense. But my question is, because you somewhere I saw you say enable query create. That means the new version for the materials view advanced version. That's why I was just
Where please? Where did I put it?
No, not here. I say.
And where do you see that?
Now, when I was do my research, that I saw like you say when you got one table is like 1 million row, and you can just recalculate to create the material view. You make this table like a small and like 10,000 row. That means like if you wanna go see the data, you can just pass from the Oracle just go send you to materials view. If you want a more detail, and then you go, the Oracle go send you for the big table. But that's no problem. That's what I was just saying.
Yes, yes, you are completely right. Everything will depend. Oracle will always try to. That's why I said Oracle will always try to see the cost of using the material views or going to the table. That's why I made mention of query transformer when it comes to performance tuning. The end user doesn't know what's going on. But if Oracle sees, or if the server process sees that using the table is cheaper, then it will go to the table. But if it finds that using the material view is cheaper, it will go to the material view. Does it make sense?
Yes, sir.
Yeah.
Thank you.
Give me, okay, no problem. 1 second. Sorry, I was returning a call. Okay. Don't want to spend too much time on the phone since we are almost at the end. Are we getting the concept of what I just said about material views, please? Just the basic concept. We know we go to again. We can go deeper on presentation, but I want you guys to have a clue on what is going on here. Does it make sense, what I just said?
Yes.
Okay, good. I hope so. Good. Another one I want to also make a good clarification on bind variable. Bind variable. And I will take an example to explain an example you guys are familiar with to explain bind variable, and I will jump to the technical part. Let's assume that we have multiple people. Let's take ladies. They like to shop. Okay. Let's assume they have a platform where they are shopping. Okay. They know their platform. Okay. So let me take a common platform everybody know. Let's assume you want to know, maybe you want to go maybe to Amazon. Okay. I know they might not go there, but let's take Amazon. And let's assume that they want to buy some type of shoes. Let's assume we have 5 colors. We have multiple colors, but I know that let's assume that they have three colors they mostly buy. 3 common colors they mostly buy. The black, the red, for instance, let's take maybe the purple. No, the pink. Let's take those 3. Okay, let's assume these are the 3 type of. These are the 3 colors they mostly buy. Okay, maybe it could be sneakers. Okay, but I'm just giving a general. I'm just saying those are shoes. So other colors, they are not highly interested on that. So they have white colors, purple, other colors. They are not. People buy, but they mostly buy the black, the pink, and the red. Those 3. Now, let's assume that one person comes and buy the red, and let's assume the red is represented by a number here. So let's assume the first person come and buy, and whenever you are trying to buy, you are running a query in the database or from the application. So that query will go ahead and get the shoe, and the result will be returned to you. The second one, the black, return to you, right? So because maybe the red is different from the black, maybe you can go through hard passing if you are the first person to buy that shoe, because the first time you are buying maybe it's the first time, or let's assume you are the first person to buy that shoe. That means the query should go through hard passing. The second person buy the black shoe. That person is also the first person to buy the black shoe. It also goes through hard passing. The other person buys the pink. You also go through hard passing. Now, any other person that will come after you to buy the same black shoe or the same red shoe, that will go through soft passing, right? Because the result of what you perform is already stored in the memory. The results are already stored in the memory. So they will just go through soft passing. That's an example. But now, because ladies frequently buy red, black, and pink, we can create a variable which takes all those 3 colors, such a way that whenever somebody buys a black shoe, if another person is coming to buy a red shoe, it will use the exact same way, the exact path, the same access path as the person who bought the black shoe. So you create now a variable which takes black, pink, and red. The first time you will run the query with the variable, the first time you run it, the variable here is called B. So the first time you run the query, it goes through hard passing because Oracle doesn't know that variable yet. Oracle doesn't have those values yet. My variable should be created by developer, not you. So now, that variable now, since that variable contains multiple colors, the next time somebody comes and try to buy one of those colors, Oracle already has the cursor or the execution plan stored in the database. So that person will just use that execution plan and go to their buffer cache to get whatever he or she needs, and so on. So bind variable helps to reduce the amount of hard passing. In this scenario, we had 3 hard passing because they are looking for different values. But if you create a variable that can take all of them, it means that just the first time you run the query with the bind variable, just that time you will go through hard passing. But any other query that you will run in the future, and if those values are part of the bind variable, those queries will go through soft passing. Are we getting what I just said?
Yes.
So,
All right. So that is what happened with bind variable. But careful. And we call it, be careful whenever you are using.
Sorry, sir. Can you repeat just one more time, please?
Bind variable help you to reduce amount of hard passing. Because by default in Oracle, when you run the first query, you will go through hard passing. When you run the second one, you also go through hard passing. When you run the third one, you also go through hard passing. You see that the difference between these 3 queries is just the department ID. But all of them will go through hard passing. Okay? So it means that if you have multiple departments like that, any query you are running with just a different department ID, that query will just go through hard passing. But what if now I will give you the condition of creating a bind variable? We just wake up in the morning and create it. What if I create a variable B, and this bind variable now contain all these values, 30, 40, 50. So all these values are contained in a bind variable called B. So I will run this query in the database. Because the variable is created, right? I will run it. Once I run it, because it is a new query, it's normal for it to go through hard passing. And when it goes through hard passing, Oracle automatically will scan all the values of this variable and store it in the database. So now, the next time you are running any other query, if you specify a value that is part of that is part of multiple values contained in the variable, if it's specified on your query, Oracle will just go ahead and look at the plan that was created for this query and give it to you. So you don't need to go through hard passing again because the hard passing occurred once. But if you run a query and the value is not part of the bind variable, you will go through hard passing again. But whatever value that was created and that was added to the bind variable, if you run it on a query, automatically Oracle will choose soft passing for you. Does it make sense? Or are still confused?
Yes, sir. Yes, sir. It makes sense.
Good. So that is how beneficial they are. Because whenever I was telling you to learn about architecture, is because for every single area you can see that we can have now, maybe now you guys can know that a lot of hard passing can occur, and you can have an idea on how you can reduce hard passing. For instance, okay? So you can, this is one of the rules that we set when I was in Texas. We advise people to be using bind variable frequently. But now there's a danger with bind variable. I said that whenever you create a bind variable, all other queries you will run, if that value is part of the bind variable, automatically you will use the plan. And let me give you this example. Let me open a brand new pen document. Let's take a table of 100 rows. And let's assume our column department ID, right? We are dealing with the column department ID. Let's take these three values, 30, 40, 50. Let me even take another value that is not part of the bound variable. And let's assume we created the bound variable on, we want to create it only for 30, 40, and 50. It means that if somebody runs a query with 70, it will go through our passing again, right? Because it's not part of the bound variable. But now, the table has 100 rows. Let's assume for department ID, equal 30, we have 2 people on that department. 2 people who belong to the department. That means 2 rows. For department ID equal 40, we have 75 people belong to the department. For department ID equal 50, we have 20 people who belong to the department. And for department ID equals 70, we have the remaining one. So we make 95, 97, 3 people. Now, this one, the percentage of this, it means that 2 people out of 100 are in this department, correct? Which makes 2%. Because people, right? 2 out of 100, you have 100 people. That means you have 2%. This one will give me 75%. This one will give me 20%. This one will give me 3%. Now, for you, if I'm writing a query like this one, we said 2%, right, are on department ID equal 30, correct? Because only 2% are in the department, the optimizer may decide, let's assume there's an index created on this column. Maybe because the number of people we are looking for is very small, we just have 2 rows. Maybe the optimizer can use an index, correct? Because we say an index can be used whenever we are looking for a small amount of data in a big table. Oracle may try to check whether an index is better because we are looking for a small number of rows. So it means that maybe for this one, Oracle may use an index for the department ID equal 30 because we just have 2%. Does it make sense? Maybe for the 40, Oracle may decide to use a full table scan because it is 75%. 75% is quite big. It's even closer to, it's almost, that means there's a huge amount of rows you have to retrieve. So Oracle may not use an index. And this one as well, Oracle may also decide to use either a full table scan or an index. And the last one, Oracle may decide to use an index as well. Now, if we pay attention, we see now that here, these 3 values are part of the bound variable, but this one has a different plan. It's using an index, but the other are doing full table scan. These 2 are doing full table scan. Bound variable can be misleading because for a bound variable to be effective, we should make sure that the cardinality of those predicates is almost the same. You should make sure that the number of rows, the number of matching rows is almost the same. Because if for instance, Oracle decide to perform a full table scan on one of them, Oracle will perform a full table scan on all of them. Because all of them will be using the same execution plan. They're using the same execution plan. So meaning that even this query maybe can run maybe faster because it's using an index. We will not use an index anymore because all of them has to go through full table scan. So that's why we say to use bind variable, make sure that the cardinality or the number of rows is almost the same. It means that maybe one has maybe 20, another one has maybe 22, another one maybe has 24, or is 21. So the number should be close, it should not, the cardinality, okay, should almost be the same. So that is what it means. By doing things like this, you can, okay, the bind variable can be more effective. That's why we recommend to create bind variable on columns where the cardinality of the rows are almost the same. Are we getting that? So, and let's finish with this before we take question. And so this one is just, you know, I provided a demo for this. You guys have it, dynamic statistics. This one are just helpful whenever you cannot gather statistics in your production. You can use dynamic statistics. With this one, you don't need to wait. You can run this one, and it will help, okay, the optimizer to gather some sample statistics to provide the best execution plan for your query. Okay, so we call it dynamic statistics or dynamic sampling. Okay, so I think we are good. Any question?
Yes, I have a question on the SQL, the plan baseline and the SQL profiles. So I just wanted to know, like, how many different plans can it contain?
How many?
At a time.
How many what?
Different plans.
It depends on the how many different plans the baseline may contain, because the profile doesn't store plan. The profile is just a structure for one query that can be used as a plan. But the baseline is what can contain multiple plans. Okay. So, and the baseline, it depends, okay, on, I don't know, I cannot tell you I know how many plans, okay, can be stored in the baseline. What I know is that those plans are also managed. When a plan gets older in the baseline, it is removed. Whenever it's no longer efficient, it can also be removed from there, or you can remove it manually. I cannot tell you how many plans the baseline can take. I never thought, think about it. Yeah.
Okay, so so I just wanted to know, so for the bind variables, right, it will get the execution plan from the baseline. So would that be like a good place to store it?
Not always. What are you saying? And it depends if you decided to store, to load the plan of this query in the baseline. If you loaded the plan in the baseline, you go in the baseline. You are the one to decide whether you want to create a baseline for a query. It's not mandatory for Oracle for you to be creating baseline for all 6 SQL statements. It's using a lot of space. So if you want to create a baseline for this particular query, you can create it so that the next time, whenever a query is run, Oracle will compare what is on the baseline and the execution plan assigned by the optimizer. But you have to prepare the baseline first. You have to capture the plan of the query are stored in the baseline. Otherwise, it will not be there. Does it make sense?
Yes.
Okay, any question you can ask me. Next session is fine. All right, okay, guys, any other question? I think this one is part of the presentation. This one is also part of the presentation. And these are the documentation I used for this document. I will provide you guys with the bigger PowerPoint as I did in the morning. This was the PowerPoint I was using before, but it's too big. This PowerPoint is for those who want to try on their server, okay? Most of the things are implemented. So it's not for you to read everything, but for every example, there is a, for every part, most of the part, there's an example. Like you can see index scan. I've put some example that can give you index scan so that you can see how it looks like. Even for bind variable, for nested loop hash join here. Even for bind variable, let me see if it's here. Result cache is here. Clusters here. Examples are here. Okay. I think all of them are found somewhere here. Even bind variable, scenario, example of materialized views. Those who will present can pick and see how to create materialized view and try to implement and take some queries and see how effective it is. So I've shared this document, temporary tables I talk about. You can see how to create one, okay? How to create a global temporary table and so on. Okay, there are some information you may need here, okay? Function-based indexes, bind variable, okay? You can also see some queries and try if you have time, okay? Just pick whatever is important for you, even dynamic statistics. Okay, so I will forward it to you guys as well, okay? For those who want maybe to go a bit more deeper on some areas or to implement them. It makes sense as well, okay? Not bad. Okay, guys, I think let's meet on Monday, okay, for the presentations. In the meantime, I'm forwarding the document to you through WhatsApp. You can receive it from there. Please, this is, we are done with this PowerPoint. We proceed our learning process during the presentation. Please take this presentation seriously because that is what will help you to build a final good OneNote at the end of this program. So take it seriously and okay, and try to do your best at the group level. All right, guys. Take care. Have a good rest of your week, and we meet Monday. Okay.
Thank you.
All right. Thank you. Have a good weekend.